So the other part the other thing that completing the square is handy to do is putting an equation into vertex form, because vertex form is a squared binomial that is sometimes being multiplied by a coefficient, or has another coefficient, or has another constant being added or subtracted by. But it always has that squared binomial. So vertex form is when you have a squared binomial, which is what we've just been doing. So it's asking us to write this equation that it gives us right now in standard form, and asks us to put it in vertex form so we can identify the vertex. So the process is still the same. You just have to keep in mind that the y has to stay in the equation, because it needs to be an equation for you to be able to graph. So we still want to check, okay, is our lead coefficient in front of our x squared 1 in this case? It is. Great, perfect. So we don't have to do anything there. So we still want to subtract our c term over and then find that new c value that's going to make it a perfect square trinomial. So it might be helpful for you guys to rewrite it so that the y is on the right hand side. So I'm going to rewrite this as x squared minus 10x plus 22 equals y. So I just rewrote it so that my y is on the right, because we've been practicing moving everything to the right hand side. So now it's the same thing. We're going to move that 22 over. So x squared minus 10x equals y minus 22. So we're trying to figure out what term needs to go here to complete the square and make this a squared binomial. So again, you take 10 divided by 2 and square. So 10 divided by 2 is 5. 5 squared is 25. So x squared minus 10x plus 25. Don't forget to add it to your other side to keep it balanced, to keep it equal. So now that the left-hand side is a squared binomial, I'm going to write it as a squared binomial. So x, remember to match your sign. So minus square root of 25 is 5 squared equals y plus 3. 22, or negative 22 and 25. So the last thing to do is get y by itself, so we need to subtract the 3 over. So I'm going to keep whatever I had on that left-hand side, so x minus 5 squared, and we're just going to subtract the 3 over to that side. So now we have our equation in vertex form. I'll just write it over here. Y equals x minus 5 squared minus 3. So our vertex would be, h is positive 5. K is negative 3. Remember, the inside is always opposite. So that's it. So the process is still the same. It's just that you can't make the y a 0 in this case. You have to sort of leave the y there and just work around it. I'm going to do number 8 with the baseball, but why don't you guys try number 7, just going off of what we did here for number 6. So in this problem with the baseball, it's asking us to find the maximum height of a baseball t seconds after it is hit by the bat. And it's talking about feet. So it's nice that it gives us the equation so we don't have to worry about that. So it's saying we have this baseball, and we're trying to find its max height after it's been hit. So we're trying to find the vertex. Remember, if it asks you to find a max or min, it's just asking you to find the vertex. So we need to put this into vertex form. So I'm going to just rewrite it with my y on that right-hand side. So negative 16t squared plus 96t plus 3 equals y. Now, I know you guys hate fractions, but I'm going to leave everything in a fraction because I'm going to need to divide my entire equation by negative 16 to get my coefficient in front of t squared to be 1. So I'm going to divide And this will become t squared. And then will actually become minus because it's a positive divided by a negative. So 96 divided by 16 is 6. So that's nice. That stays a whole number. But then it's minus 3 over 16, which is not a whole number. So we'll just leave it as a fraction, equals negative y divided by 16. So I am going to leave this as y 16th and negative 3 16th. But I am going to add that 3 16ths over. So I'm going to say t squared minus 6t plus what? Because we're going to find that value equals negative y 16ths plus 3 16ths. We've moved that 3 16ths over. Okay. So now we have to say, what is 6 divided by 2 squared? It's 3. So we want to add 9 to both sides. Okay, so let's rewrite that left-hand side as a squared trinomial. So I'm going to make this t minus 3 squared. Now, on the right-hand side, I'm going to make 9 into 16ths so that we can add 3 16ths plus 9. So 9 times 16 is 144. So I'm going to just make that 144 16ths instead of 9. So now 3 plus 144 is 147 16ths. We still have that t minus 3 squared. So we need to subtract the negative 147 over 16 over to the other side because we're trying to get y by itself, correct? So I'm going to make this t minus 3 squared, subtract my 147 over, and now I have negative y over 16 just on that right-hand side. So when we're talking about fractions, if there's a fraction out in front, we want to get rid of it. We just sort of multiply by the reciprocal because that equals 1. In this case, if 16 is in the bottom of our fraction, that's what we want to multiply the entire equation by. So I'm actually going to multiply it by negative 16, and that's going to go to all 3 terms. So the t minus 3 squared, the 147 over 16, and the y over 16. So what happens is you get negative 16 times that first expression, t minus 3 squared. And then the 16 cancels with that, and you can put it over 1 if it makes more sense to you guys that way. But those 16s are going to cancel, and a negative times a negative is a positive, so 147. And here they're going to cancel as well. Negative times a negative is positive y. So we now have our equation, which is y equals negative 16 t minus 3 squared plus 147. So if you're trying to find the vertex, or it's asking you to find the max height of the baseball, the vertex is going to be positive 3, 147. So at 3 seconds, the baseball is 140 feet, or 147 feet high. So like I said, you guys could have, I guess, left those in decimal form, but I think at the end of the day, it's easier to work with fractions, but again, it's up to you. Whichever way you like to do it, or whichever you like to use, just make sure it's correct at the end of the day. That's all that I care about.